Hey guys, welcome to another video. Today is March 8th, Saturday, 2025. Don't know. Shit, 2025? Damn. Today I wanted to do a lot more C++ review. We're gonna go more in depth. I think last time we did this, it was quite helpful for me. But this time I want to focus on IPC, threads, and like concurrency. But before we do that, I'd like to finish up this memory allocator implementation so that you understand how memory is actually allocated. And so what I was trying to do here was allocate some data. So first of all, before we even build our own allocator, let's look at malloc and what it does. So every time you want to malloc use use some data, you can allocate 10 times the size of point cloud. And here size of point cloud is going to be 4 times 3 because each integer takes 4 bytes. So if you don't believe me, we'll just do this. So it's 12, right? 4 times 3, 12. And then when we print out P is going to be some memory address. So I don't want this cable is like in the way. How do I? Memory address of P, and then we're gonna free it. And so what we can do is now reinterpret cast as a point cloud pointer. P is point cloud pointer. Dude, fuck, man. P is point cloud equals P at reinterpreted, and then PC at X equals 1, 2, 3. And what we're gonna do is, if because we have 10 of these, that's what I was wondering, like, can you actually just make it an array? Point cloud piece stood, and then let's say you take another one. Why is my typing so slow? Yeah, we get 1, 2, 3, right? So can we reinterpret this? Because we allocated actually 10 of these. So what you'd be able to do is, if you want to assign the 10th element, like, you'd need to do PC plus 10 plus 5, and then dereference that, and X. Right, like this you can do too. But we know there's 10 of these, so can you just, that doesn't work. What if you just did this? So why is that different? Because reinterpret cast works, but the raw casting doesn't work. Whereas I feel like in C it would work. Interpret cast. The difference between reinterpret cast and static cast is that static cast is for known conversions, whereas reinterpret cast simply means that you are reinterpreting the bits. It needs to make sure that the size is the same. Like say from a integer UN32 to some other values for bit representation. like a pointer to. Oh. Not a simple value, isn't it? Isn't reinterpret. That's better. It's more objective. Are there things that work or reinterpret that doesn't work? Yes. Like this one, I don't think you'd be able to static cast, right? Let's just test this out. Yeah, you can't just cast. Gen. Unused. Okay, so yeah, that's allowed. Okay, so I can compile. So I don't. Yeah, you just name it. I guess you can name it point cloud. Is it? Why is this bad? Wait, point allowed? Wait, you can do that? PC. Huh. And it's all zeros for now. Like, that malloc. Does malloc 0 initially? Just pointing to start just equals. is a problem because classes don't have to have contiguous. Player already does. New is simply you can't use the word new though. How is I'm confused. Like, if that's true, why is the memory zeroed here? Like, the zero is not guaranteed. Okay. If on is this the always just use static cast into pointer type and use that pointer to store data? What more complex? Also C++. Two questions. So here are some things that I need to review. Stood array. Oh, I don't even have that. Python. Wait, that's wrong. Wait, C++ uses double into Q. Align alloc. Memory alignment. Align alloc. Okay, we need to look into this. P1 was size of a pointer is always 6. I was 8, right? So how is this? What? How is this allowed? P1 is a variable. Oh, you know you're solid. Okay, Chan. Yeah, in C, right? Okay, this is in C. We are allowed. Still don't understand how this is allowed. Malloc 10 times size of. Dereferencing P1. That's int. Size of int is 4 bytes. .24 aligned. So this is aligned to multiples of. Is this gonna change every time? It does change, right? But it's 8, 0. So 0x80 into binary is a multiple of 128. What's it? Each memory address stores. Oh, it's byte addressed, right? So each address stores a byte. In C++, we print I thought each address stored. But on hardware. What system? addresses be 64-bit because our registers can address a 64-bit address. So if each address byte we have okay, that's a lot then. I'd expect this to be 4 byte 1 int this. So 16 1 2 4 8 16 32. So 0x20 is 32, right? And the way you visualize this is it's in hex. So in hex, you can represent from 0 up to A, B, C, D, E, F. 0 up to F. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9. A, B, C, D, E, F. So there are 16 values that you can represent. Is that true? Or 15? 0, 1, 2, 3, and then up to 9. A, B, C, D, E, F. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. A, B, C, D, E. There's 17 values. 0, 0x9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 10 values from 0 to 9. A, B, C, D, E, F. Up to 9. A, B, C, D, E, F. Yeah, there's 16 values. Okay, I'm tripping, guys. I'm actually tripping. Dude, Steven, what the hell is your typing? SSE, is that a vector? So SIMD, right? Yeah. I think I actually talked about this. SSE is a vector registry. See, so I remembered it correctly. Okay. Where are we? Where are we? We need to log in. Okay, just do this. X512. Neon. Okay. Different vector. Okay. So on Mac OS, (16 bytes). So 16 is gonna be multiple of. It has to be 0, right? 16 is represented as 0, 1, 0. Is that correct? Yeah. Because 0, 0, 0, that's 0, 0, 0, x. F is 15. 0, x on 0, 16. But I get something that's 8. That's a lot. That's 8 bits plus 4 bits, like 0x80. It's 128. How was I supposed to come up with 128? How much is 64 in binary? 64 is 2, so what? 2, 1, 2, 4, 8. 1, 2, 4, 8, 16, 32, 64. 64 is 2 to the power of 7. Which is 1. 7 to the power of 7. 4, 6, 8. 4, 6, 8. 2, 4, 8, 16, 32, 64. 2 to the power of 6, sorry. Which is going to be 0, 0x what? 0x20. Fuck, 0x30. 40. 3 is going to be 1, 1, 0, 0. I see. Yeah, I'm not the most expert in hexadecimal yet. And you can do align alloc. The largest size of type. Any fundamental type problems. Damn, I fixed the tables. Does that mean poker? Actual regret. Actually crazy, it got updated here. All of these got updated because the table was not okay. Anyways. So SSC is 128-bit, which means that it's 16 bytes. Does MacBook only have SSE as its but it's not even that much better. So that's why. So if my computer has vector bits, it will see SMD. What? We see that for us, right? That's just like a 64 byte alignment. Wait, 80 is not freaking 64? What am I doing? 1, 2. A hex is 4 bits. If 4 bits, the largest number you can represent is 7. And then 0. No. What are you saying? Oh my, what am I doing? A hex is 4 bits, so this is a byte. This represents a byte of data, right? If you do bin of 0x80, that will be at most 8 bits. Yeah. I see, so it's as you fill in the other numbers. Let's 2 to the 4, 2 to the 8. 2 to the 8. No, 2 to the 7. 128, which is what 0x0 is. Because it's 1 shifted by 7. But 64 is 1 shifted by 6. 1 shifted by 6. Okay. Why is it? So 0x80 is 1 shifted by 7 to the power of 7, which is 128. Oh, yeah, you're so fucking stupid. 2 MB megabytes. Mega is 10 to the 6. A giga is 10 to the 9. Which is a billion. So how do we do this? Stood any. Okay. I'll see. That's right. Alignment. Okay, I need to go to the bathroom. I'll be back.